Okay, so we've been dancing around this definition of a limit of a quotient being a fraction, of course, being representative of the slope of a line that's tangent to a curve. In the first picture here, we see that the curve is y equals f of x, and we take a specific point, the ordered pair xy equals a f of a, and we see that we have a tangent that touches the curve at that point. And we're interested in the equation that represents the slope at that point. In the second picture, the only difference here is that the tangent is touching a point that's arbitrary. It's not x equals a as it was in the first picture. It's just a general x. And in the third picture, you can see how we actually developed the whole idea for this quotient by taking 2 points on the curve, one at x and one at x plus h, where the distance difference between the two is the value h. And we just collapsed that difference between them, and in doing so we were twisting the line by taking the limit until eventually we got the tangent line passing through a single point. But these are all basically giving us the same formula. Let's review those. In the first picture, we have a specific point for the x coordinate. We have a for x, and for y, we have the y partner to a, f of a. So we have seen the slope of the tangent line to the curve y equals f of x at a specific point, x f of x equals a, f of a, is represented by this formula for the slope m. It equals a limit as h approaches 0 of the difference between the y partners, f of a plus h minus f of a over h, and h was the difference between the x partners. In the second sketch, now we consider an arbitrary point, x f of x. No longer do we have x equals to a as we had in the first picture. Then, in the second case, the slope of the tangent line is the curve to the curve y equals f of x at an arbitrary general point x f of x is a similar formula where we have an x in place of a. A was a specific number, x is any value for x. The slope m will be equal to the limit as, again, h is going to approach 0, h being the difference between the distances between two x's. It approaches 0 of the quotient f of x plus h minus f of x over h. So you just compare those two limits that we just wrote for the first and second sketch. The difference is, in the first example, we have a real number value for the meaning of the limit, the actual value of the limit. It's equal to a real number. While the second case, we don't get a real number, we get a function of x, where we can actually plug in any x into the formula for the slope. So the first one gave us a real number where x was a, and the second limit gives us a function of x where we can plug in whatever x we need to. So in the generalization in the third sketch, it's clear that this slope is the limit of a quotient as the not. We have to remember, it's not as x approaches a number. We were doing those sorts of limits weeks ago. Now we're concerned only in the limit of a quotient. It's much more complex, the limit of a quotient. It is the quotient of the difference of x values as the difference of x values goes to 0. In other words, as the space between x and x plus h diminishes, as you can see in the sketch, as that space diminishes between the two x values, the tangent line twists until it becomes tangent at a single point. And that was represented by the limit as the difference h goes to 0 of the change in y partners divided by the change in their x partners. Specifically, it was equal to the limit, or it is equal to the limit as h approaches 0 of f of x plus h minus f of x over x plus h minus x, the difference between the x coordinates. But we can simplify the denominator of the quotient, and we have the limit as h approaches 0 of f of x plus h minus f of x over h. Okay, so we've been calling this by a name, and now we're going to formally introduce it. We define this limit as the derivative function. The operative word here is function. This is now a function that has a domain and it has a range, and we can feed x coordinates from its domain into it to evaluate these limits and get a real number in the range.